Okay, just a couple final pieces of information. Remember, in order to have a current, we have to have a source of potential difference, which again is kind of like tipping the scales of the water in order to get the water to flow, in this case, in order to get the current to move. We call that a potential difference, or voltage is the other word for that. And the battery or whatever we're using here also will be a source of energy. So the distinction between something like a battery and a generator, both of these are going to create the potential difference that's needed to tell the charges to start going. But in the case of a battery and versus a generator, it's going to use a different type of energy to kind of get this process started. So in the case of a battery, it's going to take chemical energy in the battery and convert that into the electrical energy that the charges have in order for them to go around the circuit. So that's why a battery will die. What's really happening is all of the chemical energy has been converted to electrical energy, and therefore that process is going to stop and the potential difference would go away, so there's no more energy available. Now, in the case of something like a generator, it converts mechanical energy. So something moving or spinning, like a turbine or something like that, but it's going to convert mechanical energy into electrical energy. Okay, and the last piece of information, just there are two different types of current, AC and DC, not referring to the band, of course. But direct current is when the charge moves in one direction in the circuit. So the charge is only going to move through the path one way. This is what we see when we have a battery as the source of the potential difference. One side's positive, one side's negative. The charges are going to move according to that. Now, alternating current, on the other hand, is when the motion of the charges constantly switches back and forth, or switches directions. And this is what you would see with something more like a generator. And what's happening on a generator, the positive and negative side keeps switching back and forth and back and forth and back and forth. So the electrons will be told to go this way, then that way, then this way, then that way. So they're moving, but they're actually just kind of moving one direction and then back to the other direction, and one direction and the other. So the electrons really aren't going through the whole circuit. Like the electrons in the wires in your home, that's alternating current in those wires. The electrons are just going back and forth and back and forth. They do that at a rate of 60 hertz. So 60 times every second, they get told to move this way, and then that way, and then this way, and then that way. So they never even complete a full loop or anything like that. They're really just kind of oscillating back and forth, but that is still considered a current.